Hello, Squawk and I are ready to do some more science now. We're going to have a look at what water can do, and we're particularly going to talk about surface tension. Now, in water, water is actually made up of lots and lots of tiny molecules, so small you can't imagine. And the thing about molecules is, especially the ones of water, they attract each other and they try to hold together. So that's why the water doesn't just froth about all the time, it settles down like that. Now, that has an interesting effect because it means that there's a bit like a skin on the water. It tries to hold together and it doesn't let other things in. Now, sometimes it has to. We know what happens, don't we, if we drop a metal object into water. It will sink. And it sinks because it's much heavier than the amount of water that takes up the same space. So let's see that. Plop, there it is in the water. Yes, but that's the paper clip. But let's watch what happens now if we put a paper clip in the water more carefully, like this. We've got a bowl ready and we'll watch it closely. Here we come with a paper clip very carefully into the water. Yes, it's still floating. Is it because of the paper though? Let's take the paper away now. Yes, isn't that amazing? Metal is floating in water. I think we'll try that again. Let's do another one. There we are. Now, if we look really closely, I think we can see that the surface of the water is just bending under the metal there, and the surface is holding together because of surface tension, and the paper clip is pressing into it. Let's put one more in. Yes, that's quite surprising, isn't it? They're all floating in there like little boats. And it's all because of the surface tension. Now we'll try to get an even closer look so that we can see that bending of the surface of the water now. Yes, that's pretty amazing, isn't it? And lastly, let's just prove that it really is. There's no trick. It's really metal and it really is heavier than water. There. Yeah, well that was a good experiment, wasn't it? That was very successful. It's nice when our experiments work. Now, there are ways to make surface tension weaker, and one of the substances that does that is soap. It breaks down the forces between the water molecules and it makes the surface tension on the water weaker. So we've just got a little bit of fairy liquid there, and we've got some pepper. And what we'll do is sprinkle pepper on the surface of the water and then have a look. So there's the pepper. Oh, is it making you sneeze? Sorry. Right, there's pepper on the water. Now I think we'll look at this closely again now. There, a bit more pepper I think. Can you see the pepper floating on the surface of the water now? There. That shows us where the surface is. And now let's look what happens when we just drop a little bit of soap into the middle of the surface. Watch this. There. See that? The surface tension over that part of the water is weaker than the rest, so it's pulled the pepper all the way apart to the edges. I think we could try in one more place like this. There. Shall we do that once more? Yeah, let's have some fresh water to do that with. There, we've got nice clean water now with no soap in it, which is important at the start, isn't it? And let's sprinkle the pepper on it once more. Here we go with the pepper. Yes, it can make you sneeze. There it is. And then we'll come with a tiny drop of fairy liquid and see what the soap does. Watch this. Lovely effect, isn't it? You can see the pepper is pulled away from where the soap went into the water. And the water is still swirling and moving around again, so I've got a chance to do another one. Here it goes. Lovely circle. Yes, that's the pepper moving around, showing us where the surface tension is pulling the surface of the water. Yes, we've got more water now, and now Squawk and I are going to show you the difference between science and engineering. Science is when you notice an effect, like the pepper moving because of the reduction of surface tension, and then engineering is when you think of something to do with it. So first of all, we're going to pour water into the tray like this, and we're using a dark tray now so that we can see paper floating on it in a minute. No, don't start drinking it, it's not ready yet. Right, and we'll let that settle down for a bit, and now we'll have a close look at what's going to happen. A specially shaped piece of paper now. Can you see the shape of that? It's a triangle, and it's got a hole and a slot cut in it. Now let's float it in the water like this. There, it's floating in the water. Oh, it's curling up a little bit. I'm positioning it where I want it to be. And now watch what happens when we drop a little bit of soap into the hole at the back. Oh. There. It's like a jet effect, isn't it? I don't think that one went very well, did it? So I think we'll have another go at that, shall we? Here we go again. Here's another one. Float carefully on the water. And now here we come with the fairy liquid. There. That's quite fast, isn't it, when it gets going? We'll try that a couple more times, I think. Yes, that was a good one. Well, we enjoyed that experiment with the rockets shooting across the tray, didn't we? All because of surface tension. Now, water isn't the only liquid that has surface tension, although it's the most easy to demonstrate. But we'll try another experiment next, which will look a little bit more interesting, perhaps. Right, let's get ready for that. Right, now, for our last experiment on surface tension and what liquids do, we've got some different liquids here. Of course, we've got water as usual, so we'll use that. We've also got some methylated spirit, and we've got some oil. And we might know that oil and water don't mix, and that's because of surface tension. So let's see that. Let's put some water in a glass. Okay. No, don't drink it. There's the water. And we'll just put a drop of oil in that as well. Here we go. Are you ready? There. And look at that. The oil has floated on the water. Now, it's actually surface tension which makes the boundary between the oil and the water so that they don't mix. Because the water molecules are connected to each other and the oil molecules are attracted to each other too, but they won't go together. And it's made globules that stay together on the surface of the water. Now the oil floats on the water because it isn't as dense as water. A certain amount of oil is not as heavy as the same amount of water. But we'll find now that it's different with methylated spirit. Okay, let's put some methylated spirit in the glass. And a little bit of oil in there. And look at that. So do you see the difference now? This time the oil is at the bottom. It's sunk right to the bottom, but surface tension is still keeping it together. And that's because oil is denser than methylated spirit. Now you might think, what will happen if we put methylated spirit with water? Will one float on the other? The answer is no, because they actually mix together very well. And that raises an interesting possibility, doesn't it? What if we have some oil and we have a mixture of methylated spirit and water which is the same density as oil? Shall we try to do that? That will be a good experiment. Now I'm going to start by tipping all this into a bowl. Right, I think we'll have to have a closer look in a minute. But I'm just tipping things in first. So now there's some oil, and there's some water, and there's some methylated spirit. I'm going to add a bit more oil because I don't think it's enough. There's a nice lot. And I'm going to add some more methylated spirit too. And then we'll have a close look, I think. There, that's nice. A little bit more. Now, the mixture of methylated spirit and water has got the same density as the oil, so the oil floats in it perfectly. And now, what's the surface tension doing? It's making the oil form together into spherical droplets like little balls, isn't it? And I like this effect because it looks like a miniature solar system, doesn't it? And sometimes when two balls of oil touch, they merge together into one bigger one. And I think we're going to see big planets forming in the middle soon. So we'll watch this for a bit and see what happens. I think we'll have a look from different angles. There now, Squawk and I really hope you've enjoyed our experiments with surface tension today. Floating metal on water, making the surface tension retreat by adding soap. We made some good soap rockets, and we've just demonstrated how oil floats perfectly in a mixture of methylated spirit and water. See you next time for our next experiment. Bye.